Hello, welcome to the third lesson for the React WhatsApp project class. Let's see, last time we worked on setting up the profile, the route to set up the profile. We wrote some validation code, we wrote some tests, we set up the test with Mocha, Chai. And we created a route that creates a user. Let me check that. Add a validator and then routes user. Yeah, it creates a user. If I remember correctly, we tested it through here. Yep, and returns the number of users. So the route is created. So the next thing we wanted to do was to learn how to use JWT tokens. And JWT tokens are a scheme for authorization. It's a way to do authorization. So we're going to create a token. The token is this long encrypted key, a token that will encode the user's handle. We use it as a quick way to authenticate requests. So the API will sign the user handle using a key. That way, only the API can decode it, the API on the server. So note that the token doesn't expire, which is really not ideal. For a proper JWT implementation, I added a couple links here. So the idea with the tokens is that when we're creating a user, right? So the application is going to have that first screen that's going to prompt the user to, let me see if we can pull it up in Zeppelin here. Here, the first time the user logs in, they're going to see this screen, which prompts them to create a user with a handle and a name. So after they submit and the request is successful, so after all the validation passes, the API is going to return a key, a JWT token to the client in the response of creating a user. And then the client is going to store that token in its local storage. And then what's going to happen is that subsequent requests from this client, they're going to be done using this token, and the token is going to be set in the authentication header. So, and what that does is that since we're going to pass that token every time we make a request, then the API is going to know which user that request belongs. And not only is it going to know who, but it's going to be able to know that that's the actual user. Because if we just pass a handle in plain text, then anybody could impersonate anybody. Right? If I create user Agent Smith here, and then I have another user that says, that just passes Agent Smith in plain text, then there's no way to secure that. There's no way to know that's actually that user. So what we do is that we're going to encode all the information that we want in this JWT token, and so that only our API server can decode it. So it's a way for us to quickly authenticate requests on the server side. And so what the client side has to do is that after the first time they get this token, they have to store it. And what I was saying is that they don't expire, which is not ideal, because the longer you have a token out there, then the possibilities for somebody else to be able to intercept that token increase. So what typically happens in production is that these tokens expire every few minutes. And then that means that you have to refresh them also every few minutes. So we're not going to set that up right now, but you should know that's what you have to do. So here's a couple links on how to refresh tokens, what are they, and when to use them. And also an introduction to JWT. JWT stands for JSON Web Token. So what we're going to do is that if the validation succeeds, we'll return the JWT token to the client, which will encode the user's handle. That way, when we pass that token back to the API can decode it and find out the user's handle. So to do that, we need to install JSON Web Token. Let me see what we got here. We're installing JSON Web Token. Okay, so now we're going to return that. And now we are a little bit behind. We're supposed to be like a few here in add contact. So I'm going to try to skip ahead by just reusing a lot of the code that's part of the solution. That'll be source, API, routes, I think. Yeah. So import JSON Web Token. Routes, that's where we are. Here. And then what we're going to do is that once we have the user, we're going to assign the user's handle with a secret. And the secret is really anything we want it to be. Yeah, some secret. This usually is like some key. It could be any value really. The secret, and then we're going to assign that token like this. So after we create a user, we say user saved. So now what we're going to do is this. So we create a token using the JSON Web Token library that we just installed. We're going to assign the handle. We can assign an object with many properties. We can assign the handle and the name if we want as part of that token. But for now, we only need the handle. And then we also pass the secret that we're going to use that you should only keep in your backend. And then we're going to respond with that token. And by convention, you call this type of tokens also bearer token. And the way you set those up is that you prefix them with the string bearer and a white space. So now when we create a user, we're gonna get this token. So let's see if that's working. Yeah. So this is the token that was created. This whole thing, and this long string has the handle name encoded, the handle encoded, the user's handle, which is in this case triple D. So now the client side is going to have to, when we do the actual application, it's going to have to store this token for subsequent requests. And verify. So I'm going to expose a route that usually you don't want to expose. This verified route. This verified route is going to verify a token. But usually you want to do the verification only on the back end. You don't want to expose it to the front end. But I'm doing it just to make this a little bit more testable, to show you guys what is actually happening when we verify the token. Right? User verify. And we're going to pass that token in the authorization header. This one. Okay, send. Okay. And it returns with the decoded data. We had decoded the user's handle, which was triple D, and when we had encoded the user's handle, which was triple D. And now when we call this route, which decodes that token, it returns the decoded handle. And in this case, we see that it's triple D. So that's how the backend is going to use it. It's going to grab that token, it's going to verify it, and it's going to decode it. And it's going to know the actual handle, and it's going to be able to perform the request. Like add a contact or send a message on behalf of some handle. So with that. Okay. That's it. Let's set up SAS. So we would like to require SAS files from within our React components. SAS is a technology that helps you write CSS. It provides functions, mixins, variables, nested styles. So it's a better way. It's a nicer way of writing CSS. So I recommend you guys to use SAS, something like SAS or Less. It's also very popular. Even Stylus is pretty good. So to set up SAS, to be able to use it from our React components, we need to set up Webpack and SAS. There's a loader that will bundle our SAS files, but it needs other dependencies to work, unfortunately. So we're going to install all of these dependencies just to get that CSS SAS working. We're installing the SAS loader, Node SAS, style loader, and CSS loader. And these are all loaders for Webpack. Sure, this would work. I guess this SAS loader required Webpack 2.0. So let me install specific versions then. Cool. CSS loader, Node SAS, SAS loader, style loader. So we got all those versions there. So to install specific versions of a module, you put the module name and then you do add and you put the version that you want. Node SAS, 3.3, style loader, add, 0.15.1, CSS loader, 0.25. There we go. See how that works. I'm gonna see for next class I can bring everything up to Webpack 2.0. Cool. That looks better. No warnings or unmet dependencies. Okay. So we're gonna configure that loader in Webpack. Grab this, the Webpack config, which is right here. So we already had a loader. We have Babel loader. That means a loader is something that runs with based on the files that you specify it should run on. For example, this Babel loader is specified to run on this on anything that ends on .js. Any JavaScript file has to go through the Babel loader. Now, any SCSS file is going to have to go through the SAS loader, which puts it into CSS, and then CSS loader will output CSS, and then it's going to have to go through the style loader, which puts your CSS in the style tag in your document. This is why we installed all these modules, is because we needed to do, we needed multiple ones. You know, the SAS one just outputs CSS, and the CSS outputs style, and the style outputs in the tag, in the head tag in your HTML document. Okay. Another good thing to do is to normalize your style using normalized CSS. So we can grab that. Install it, or you can install it, or you can just grab the file and put it in your directory. Or we can just grab it from here. Source, spot, normalize. Well, and also we're going to use the CSS as an example of how to require CSS or SAS files. So source, normalize. Here we go. So that's normalize. And then this is our entry point. So what we're going to do here is that at the entry point level is where we're going to actually import also that normalize CSS. And really that's all there is to it. Through Webpack, it's going to get imported right into our application. To see that working, we're going to go, what do we have? JSON test, Heroku app, local. So this is what it looks like here without normalize. Let me see if normalize, we're making changes to this thing. I don't think it will. Is this running? I probably need to restart it. When you make a change to a Webpack config file, you need to restart the Webpack dev server because it doesn't automatically reload Webpack configuration. Let's see what happened. Canonical module normalize CSS. Import. See if that works. Nope. Unexpected token. Because our loader is only loading, it's only checking for SAS files and JavaScript files. When we say import a CSS file, it doesn't have a handle for that. It doesn't know what to do with it. So what we could do here is we could just change this file name to a CSS. And that works because CSS is a subset of SAS. Maybe compiling. There you go. Successful. So now that it's normalized, you see now that the font is different, right, than this one. So normalize is actually applying. It's normalizing styles across all browsers. You know, that's what normalize does. Here, it's like a CSS reset, but it's an HTML5 right alternative. Normalize makes browsers render all elements more consistently and in line with modern standards. And it targets only the styles that need normalizing. So it's a good practice. And that way your page looks the same across all browsers. And now if you go to elements, go head, you'll see a style tag in your head. And that's where all the styles are going to be. So it kind of injects the styles there. That's what the style loader does. Normalized. Okay, view to submit. a profile. So we're going to create a React component that will submit a profile because we already have the backend. Feel free to use the UX provided. The spa will use the route to create users when submitting a profile. So when we submit a profile, we're going to make a request. So we need to manage that request state. The request has several states: default, in progress, success, and has error. So these all 4 states are part of every request. I have to make sure you render the correct view for each request state. If the request succeeds, we're going to store the JWT token in local storage so that it can be used for subsequent requests and sessions. But be aware that some browsers only give you 5 megabytes of local storage space, which is more than enough for storing the JWT token. But if you rely too much on local storage, you might bump into that 5 megabyte limit. AJAX requests should pass authorization header and cache control headers. We're going to look at that. A little bit of homework there to use the validator that we wrote last class on the client side also to validate that the handle and the name are provided. And then we show messages to the users based on those validation errors. So let's grab that code. Spa components. 823. Do I contact? I'm going to jump to the solution since we are running behind. I'm going to jump to the solution branch. So let's see. See if there's anything pending. So chai. Build API. Yes, linked. React key mirror URL validator. Okay. Okay, let's see where we are here. So, now we have key mirror. Really. Okay, that's good. Had to restart the Webpack dev server as well. Maybe. So that's what we're gonna see how we do this. So in the spot folder, in the spot directory, I created a components directory which has all of these components. There's going to be a main SAS file for the main container. It's here. You're going to see how we import main. The main container is called from the app. Let me make some bigger. From the entry point, it's going to render the main container. We go there. we see the constructor, the render function, and we see that the main container, what it does is it calls a component to set up a profile. So this component set up a profile. What it's doing is had it has state. It's the one that has the actual state. It has a handle, the name, and the state for the request. And it knows what to do when the name changes, when the handle changes, and when the name changes, and when the user clicks on submit profile. It has functions, has callbacks for all of that. So what it does is the contents are gonna change based on the state of the request. Right? So initially, when the request it's in its default state, so before it gets called, it's going to render this. It's going to render the profile editor, which is this white box we see here, and the submit button, which is this green one here. And these two are positioned now with CSS. Yeah. So the layout is given by the React component. The styling is given, and the positioning is given by CSS. In the set profile, there's a setup profile SAS. So setup profile container is position relative, and then the profile editor has an absolute position. Submit button is also an absolute position. So the cool thing about these React components also is that each React component can specify its own SAS, its own styles. You don't have to have one style sheet with all the styles in your application. You can have different ones. You can break them up in ways that make logical sense, and you can reuse them better. So if you have like a component, a button, some type of primary button component with its own styles, you can put the style right next to it. So every time somebody uses it, they're also gonna reuse the styles. And that way also when you need to refactor, you know exactly what styles are being used by which components. So, and this is another way to require SAS files, is to use require instead of import. But both are the same. Import's probably more consistent. It's probably a slightly better option. We have render contents. So yeah, so also we see here that it's already managing the request, right? When the request is fetching, which means that the request is fetching, what we're going to do is that the text is going to change to submitting instead of submit, and that it's going to be disabled, right? Yeah. So it's only enabled when it's not fetching. Also, if it's successful, we're going to swap out the entire UI and we're going to just replace it with a div in the span that has a message that your profile has been saved. And if there's an error, also we're going to replace the whole, the state is going to change. You're not going to see the profile editor or the submit button, you're just going to see this message that there was an error. And this is a function that submits a profile. When the user clicks submit, this function is going to get called. It's wired up here. Submit button, unsubmit, submit profile. So before we actually call this request, what we're going to do is that we're going to set the request state to fetching. Okay. And then when it's successful, we set the request state to success. Or if there's an error, we set the request state to has error. And this is we're going to use to make remote requests. We're going to use the jQuery Ajax library. I wrapped it in a global set timeout so that you can actually see the different states. You can see it from fetching to successful or from fetching to error. Because we're running everything local right now, so it's going to be very fast otherwise. And these are things that you definitely need to take into account, because you're going to put your application out there, and most users are not, no matter, depending on the context, depending on their network, where they are, what they're doing, the request could take a while, right? So it's important to be able to manage those states. So what we're going to do is that we're going to call that user route that we created as JSON, and we're going to post handle and name. And then the route, remember that that route returns a token. And we're gonna set that token in local storage using set item and using the key user dash token. Since it's in local storage, then subsequent requests can actually use it. Okay. So that's a profile. We also have a profile editor. I remember we've encapsulated things. Yeah? We have a profile editor, which is just the white box here on the left, and the submit button. The submit button is a different component. So if we go to profile editor, we're going to see that it is actually, it has the handle and it has the name. This style of React components is called stateless React component. A stateless React component is basically just a function. It's a function that takes in a state as input and returns a visual state and returns a view based on those inputs. And this one takes a handle, a name, and 2 callbacks to manage the change. Every time one of those changes, every time the handle changes, every time the name changes, it's just going to return a different representation of the UI. So here, as I'm typing my handle name, Snowflake, the UI is getting updated. The name is always going to be different, and this is what's actually rendering that name. So profile again, submit button. Submit button. It's just 2 divs. It's not really a button, but it has 2 divs. And when it's enabled, it's going to have a click handler. And when it's disabled, it's not going to have the click handler. So user won't be able to click on it. Profile editor. We also see that profile editor has its own SAS also to manage the label style, the input style. So here we see Snowflake, submit. We see submitting is disabled. I can't really click anymore. And it says your profile has been saved. Your handle name is Snowflake. And all of this interaction was just this one React component. One React component that managed the request state. And they used other components. It was this setup profile.react. So it used these other components, a profile editor and submit button for the initial default state of the request. And once you hit submit, the button changes to submitting, is disabled. And then once it comes back successfully, it prints out that message. Your profile has been saved and your handle name is such and such. And also we saw that local storage was saving the user token. So if we go to console, we could just get it from local storage here, JWT. Oh no, user token I think is what I used. There you go. You can also go to application, local storage, your domain name, and then you can see user token here. These other ones are from another class. So you see how the data is persisted because of the domain. I saved in other classes, I saved these keys to local storage, and I also use port 5000, so all that data is persisted. But this is the one that we just saved right now, this user token, which is the one that the API returns. So we see that profile has been saved. Also, there was another state, right, that we didn't test, which was has error. So we want to test that. So the way to test that is, and I think I showed a little bit of it last class, is that you can use the React tab to simulate different state values. So set a profile, request state. I'm gonna go with has error. I'm gonna see, we see what the message is when there's an error. With fetching, it changes. This is disabled. there's no way to make a request. We will put default and submit, and I should be able to click it now. You can change the handle name. And handle updates us. Cool. Yes. Yeah. So we tested all states here now. Okay, so we're able to submit a user. When we submitted the user, we did a post. And this is the post. To the user route, we posted. And what did we post? Headers. Request payload, the handle and the name. And then the response that we got was this, a token, a bearer token. And then our code is stored that on local storage. Okay, so we're gonna see this in the next section. Now we manage all the request states. Okay, great. So the next thing is to add a contact. A profile. Okay. So add a contact. We're gonna store stores and folder structure. We'll talk about that. So we're gonna leverage a base store to reduce the Flux boilerplate. We're gonna prefer to organize your folders by feature. So now we're adding more features, right? We had just before we only had a submit profile, but now we're gonna be working on adding a contact. So we need to organize things a little bit better because everything is under the spas folder. So to do that, we're gonna use, and also the state is gonna be a little bit more complex. So we would like to use something to manage the state across the entire application, and that's why we implement a pattern like Flux. So we're gonna use a base store. We're gonna see how we're gonna do that. A base store is a store that all the other stores are going to derive from, and that's going to help us reduce some of the boilerplate code. We'll also see how we can organize our folders, and we're going to start working on the add contact view, and also this is something I call the zero state, for when there's nothing in that view. Because add contact, you're going to add multiple contacts, and at first you're not going to have any contacts, so we need to handle that case when there's zero contacts. And then we're gonna create a model. We're gonna see how we create a model to be able to add contacts through this model. And then how the user should be able to close the model, and also reusable components. We're gonna do a little bit of refactoring for the to see how we can reuse even more stuff. So let's see. There's a solution branch. See if we're gonna have enough time. Yeah, I think so. Okay, give me 1 second. It's getting pretty hot here. Let me, hopefully you can still hear me. I'm gonna create a branch for all these changes. I'm gonna call it release 2. Okay. So now we see that I'm focusing on the UI now. So we have all of this under components, right? But we're gonna have, we're getting ready to have some discrete features, right? What a feature is to create a profile, and then another one is to add contacts. So we're gonna be adding directories for that. Profile, chat, which is where we're going to put our contacts. We add a contact, and then we add a chat to that contact. We want to chat with that contact. And then we're going to add something for common stuff. So all the profile stuff can probably profile can go to the profile directory. Webstone helps us change all this reference so they point to the right place. Common, I would say submit button probably should go in common. That's going to be used from multiple places. Just if we look at our mockups, we see this button here, the submit button. Which is very similar to the edit profile. Chats page, add contact also. We see here the submit button also to add contact has very similar style. Even though it is not full width, but the background color is the same, right? The corners, the font, all that stuff. So I'm gonna try putting that. And submit button, does it have? Yeah, and submit button itself doesn't have a style. The style is provided by whoever uses it. So in this case, for example, profile editor was it? Set profile probably. The submit is the one that gives it its style. So let's put submit. Okay. So we have main container, main model. Okay, chat. So that profile, we got chat. I'll use similar file names as a solution. So to add a contact, basically we need a way to, when they click after they're done adding a user, we need to navigate the user to this view. Okay. So the first thing that we have to do is we got here. We're going to be organizing a flux pattern. So we have components. In flux, you're going to have some enums for your actions. I usually have a folder I actually call flux, which has your stores, dispatcher, any actions also. And also this flux directory has, has stores, action types, and is organized by feature, not necessarily by actions and constants and stores. Because when you do that, you end up having to jump around many directories because usually you're working one feature at a time. Default is for anything that's really not feature specific. Here, base store, and the dispatcher at the top level of the flux directory. So this is pretty boilerplate code, very simple code. It's just grabbing this stuff. Basically, the Flux module only exposes a dispatcher. So what we have to do is we need to create a new instance of that and then expose it to the rest of the application. And this is like a singleton in the application. Everyone's going to use the same dispatcher. We go to the base store. The base store, like I said before, it helps you reduce boilerplate code. It creates some getter. It dynamically creates getter functions for your state, and it also helps you exposes functions that so that components can start listening to your store. Okay. So I will see how that's used. Store chat default. So default is the first one I would say. So we're going to have a default store that's going to manage this, the view, which view to show. Example. When we submit the profile page, right? When we submit successfully, the application is going to have to know that it needs to go to this view. A view that has a chat tab and an add contact. And that's when you click add contact, it should show the model. And when you're done with that model, it's going to show that the same chat window, but with one chat for the contact that you just added. So we need to do something to be able to manage all of that. And that is what I'm calling here the default store. So let's go, let's see this default store. So this default store, yeah, something's missing because we haven't added components up there yet. So this default store, what it's doing, state, initial state. Okay. So a store is going to do two things. It's going to modify its own internal state, and it's going to handle actions. Okay. So if we looked at, I have this thing called a state modifier, which is actually the thing that, the object that actually modifies the internal state of the store. We go here, we see the initial state. And the initial state is going to be main view and a model key. The main view is it depends on what you have in local storage. If you already have the authentication token, then you're going to go to the chats. If you don't have that, then we're going to show you the profile. So that this is the main view state. That's what it's gonna, this default store is gonna track. And it's also gonna track which model key to show, which model to show via this model key. If it's null, then there's no model to show. So initial state, like I said before, depends on the token, what we're gonna show. And also it has functions to set the main view and to set the model key and to close the model. And we close the model merely by setting it to null. So these are the actions that it's going to handle: set main view, set model key, and close model. Pretty straightforward. So this default store extends the base store, right? And then the base store is reduces a lot of the boilerplate. Like we don't have to expose and add change listener, remove change listener function. Just by adding things to our state. Yeah, the base store is going to create getter functions for those. So the rest of this, the application is not going to use its internal state directly, but it's going to access it via getter functions. Okay, so what are we missing? Some of the pieces that we're missing here is that we're missing the actions that are going to trigger this. Default actions. Go to chats view, open a contact modal, close modal. Okay, so default actions. So the actions, this is an action creator, and in Flux, the action creators are the ones that have functions that describe everything your application does, right? Any dynamic behavior or any actions. So here we can see that application is going to be able to go to the chats view. So once a request to create a profile is successful, we're going to go to the chats view. So this is an action. We're also going to open the add contact modal. So after we're in that view, the user clicks add contact, and then we need to show that modal. So that's an action. And then there's also an action to close that modal once the user is done with that. And to do that, we create these action objects, and each action object has a type. Set main view, set modal key, those are different types, and close modal is also a type of action. And some action objects have payload, and that payload is going to be represented by this data property. And this data property has a view, and the view is going to be main views chats. So when we want to say go to chats view, the action is set main view, and the view, the data part of that action is to set it. The view for that is going to be main views chats. So we say set the main view to this view, to chats view. And then here when we open the add contact modal, the type is going to be set modal key. We're going to set the key for the modal, and then we also pass which modal we would like to show. In this case, it's going to be add contact. And then when we close the modal, the action object only needs a type, because when we close the modal, we don't really care which modal we want to close, because there's only ever one open at a time, right? So we don't care which one is we want to close. We just want to close whatever is being shown. So in that case, we only need the type. And then after we create each of those action objects, we just dispatch it with the dispatcher. And the dispatcher is this object that we created here, or this instance rather that we created here, that's exposed to the rest of the application. Okay. So now we need the default action types. Right here. This just declares all the possible action types that this default context could handle or could fire. Set main view, set modal key, close modal. Enums, main views, modal keys. So I create this directory called enums, and in enums is basically going to have modules that just have values for different enumeration objects or different constants. So we're going to have main views. I'm going to have modal keys. So there's really no support for an enumeration type in JavaScript, unfortunately. For those of you that have experience with strongly typed languages like Java or C#, you're used to having enumeration types, but you don't have that in JavaScript, so you can't really do modal keys equals add contact, add profile. That's just not valid in JavaScript, because these are really properties of an object. So the properties of an object need a value, right? So the way to do this, one way we do this in JavaScript is to repeat it here. Add contact if you want. Add profile. But that's obviously already some duplication there. You can also, instead of using strings, you could use actual values, actual numbers, for example. And you could do that, but then you have to know what the code is, because in essence, what you're passing is the actual code, and then that works well. But it's a little bit easier to maintain if the value is a string, because to troubleshoot rather, because you're going to see, instead of seeing a 0 or a 1, you're going to see what the add contact or edit profile has more meaning. So to avoid the duplication that I had before, we're going to use a module code. What was the name? Key mirror. And what this does is that instead of doing this, we can pass an object with properties whose value is null. We just wrap it with key mirror. Yeah. Okay, model keys, key mirror, contact, edit profile. And then we can export this model keys now. So key mirror, what it's going to do is going to return an object that has where the property add contact, the value of the property add contact is add contact. So it's going to be equivalent to what I did before, but we don't have to rewrite everything. We just pass nulls. The same would be for main views. Constant main views equals chats, I think was one of them. Sorry, I don't really know how to use key mirror. Chats, no. That's a profile. Let's see, how did that? Spa, enums, main views, setup profile, and chats. Model keys, add contact. Yeah, we'll just have an extra one, that's fine. Right. Let's look what else we need here. Mr. Default store. So we got a views, action types, local cache keys. So this is something I added in this solution to make to help us manage local storage a little bit better. And give me 1 second. Okay, sorry about that. Okay, so local cache I was talking about, right? So the thing with local storage is that local storage only stores strings, right? It doesn't, it's a key value store for strings. So your key is a string and your value is also a string. Yeah. So let's say if you want to store a number or an object, they're going to be, you have to store them as strings. So you have to serialize all of these objects. Right? So so if you have this, if you need to work with objects, then you always have to remember, every time you use local storage, you have to remember to stringify it before you put it in, and also to parse it when you get it out. So to give us a richer interface, I created this thing called local cache, which I don't have here yet. Item 4, which basically gives us 4 functions to deal with that. So source, pause, utils, maybe. Yeah. Yeah. So we're also going to create a utils directory for utilities. This one's going to have a local cache module. So, for example, as I have 4 functions, you know, it's going to be get string, set string, get object, and set object. So if we want to set a string, use key and value. And it's very straightforward because local storage also works with strings. Okay. And also if there's an error, we're going to catch it and we're going to print out the local storage may be full. And to get the string, we just get the item from local storage. So pretty much the same as what local storage is doing. The advantage of this module comes when using get object and set object. When we set an object, key and value, this function is going to assume that value is an object. So before we put it in local storage, we stringify it. We stringify it, and then we reuse set string function. And then to get the object, we're going to parse what we get out of local storage through the get string function. So then the rest of the application can just work with set object and get object and doesn't have to worry about stringifying or parsing or all this stuff. Another thing I added to make working with local storage a little bit easier is to have this module called local cache keys. Since we're probably going to be using the values from local storage from different parts of the application, it would be good to centralize the keys to them and how you access those. So for example, we're going to have a key that stores the auth token. And it's always a good idea to version these guys. Version 1, version 2. And that gives you flexibility that if you deploy a new version of your software, you can just change the version. And then you can still work with the old version, so there's some type of migration. Or know that the user is still in an old version, so they probably need to refresh the browser, upgrade their application. All that, actions, model keys. So that was default store, and default store manages the different views. So now that we have that, we need to use these actions, right? These default actions. We're not using any of them right now. So we need to use go to chats view. And once the request is successful. Profile, editor, set up profile. So here, once the request is successful, we're going to do that. But also, before I go there, source bus. container. Yeah. So right now the main container is very simple. It only renders setup profile and doesn't render anything else. And the main container is our top level component, right? If we go to the entry point, app.js, you see main container here. And that's the top level. So this is what needs to manage the state, internal state of the application. So to do that is when I have to get the state from the default store. And now it could be set up profile or it could be chats. We get set up profile, need access to the default store. Default store. We also need to be able to take a look at the main views and the model keys. Views. And then now to get this going, we're gonna chat. So it's gonna say go to chats view. So we need to go somewhere, right? So it's gonna be chats. We don't have that yet, but we're gonna create it. Chats. Don't have that yet. That's okay. What are we here? Main container imports SAS file. Let's put that down here. It's more clear where it is. Okay, state. So now the state, it doesn't have any state because it always only renders a setup profile. So what it needs is to be able to get the state from the store. Okay. So we're gonna have this function, this get state. And get state, what it's going to do, it's going to get that from the store. Main view, default store dot main view. And this is a getter function. We're now going through the internal state. This is a function that the base store dynamically created for us. This is what I mean. And one of the reasons it's useful to have some type of base store, it reduces that boilerplate. Otherwise, you would have to create getter functions for all your state. Or expose your state to the rest of the application, which is generally not a good idea. Store the model key. Okay. So state's gonna be that. What else do we have here? After you do that, so we're gonna render different things based on different. Well, we're not really working with models yet, so it's just main view right now. So the render function is the one that's gonna look at that main view. So we're gonna switch on that main view. And what we're gonna switch? We're gonna switch on the different values. So main views dot when it's chats, we're gonna what we can do here. We just return. We're gonna have a value here, content. Let. As we let because we're gonna change it. Won't be constant. Content is going to be equal to chat. when main view is equal to set a profile, then the content is equal to set a profile. And we break. On default, we're also just gonna on default the content. So let's say for some reason there's a bug and or somehow we get a main view that we don't expect, right? We could just do something quick here. You could create like an unexpected view component. That's probably what you should do. But here for simplicity's sake, you can do this unexpectedly. You can throw also. That's up to you. You can use throw and it will stop the rendering. So here what we're going to return is the main container, and inside that main container we're going to return the content. Okay. So it's handling that the different values of main view, but what's not doing is that it's not actually listening to the store. To do that, I'm going to go here and grab this. The store change, which is going to be right down here. These three functions are how this view listens to the store. When it mounts, it's going to add a listener to the default store, and the listener is going to have a handler, which is this handle store change. And then when it unmounts, it's going to remove that listener. So handle store change sets the state using this function that we created, and that gets the main view from the store. And then after it gets the state, it's going to call this render function. I need to fix disable inspection. Okay. Yeah, then the render function is going to render the right content based on that main view from the store. So the only thing that we're missing here now is a chats component. This is one cool thing about WebStorm. You can add. I actually added these live templates myself and help you with that. Yeah. Just develop a little bit faster. So chats, what we're going to do here is just return span, some placeholder for now. Chats. Okay, so to get it to show that view, we need to call this action. I can go to chats view. And we call that when the request to create a profile is successful. So it'll be from here. Okay. Now notice how we're still using the old local storage way of storing things. So let's use the actual things that I created here. Cache and local keys, local cache keys. So here, instead of saying that, we're gonna go local cache dot set. It's a string, right? Local cache keys dot auth token, and the value is gonna be rest of token. Okay, so that helps us. The rest of the application is going to be using this auth token. We're not going to copy paste this user dash token. This is not as maintainable because every time you need to access the user token key, you're going to have to make sure all your strings are the same key. But if you use a getter, a function to get it for you, then you don't have to do that. Like this. That. Okay, stay success. Now what we're gonna do is we're gonna leave it in the success state for a few seconds, and then we're gonna navigate, just so you can see that it succeeded and then navigate it. So we're gonna set timeout. And this is more for us, for development purposes. So now we need actions. Default actions. Flux default actions. So now we go to default actions dot fill chat view. Fill chat view, and then the store should change its own state. You should emit a change. We go. We set the main view, and then we made a change. And then the main container is listening to changes for that store, and it will detect, it will be notified of that, and it will go and it will grab the new state from the store, and it will re-render itself with the chats view, not the setup profile view. So let's see if that works. Canary is a module Flux. I may need to do an npm install, or I don't have Flux yet. Yeah, so I need to install npm install Flux. Chimera also probably. Chimera is there. So just Flux. Okay, that works. Console here, main view is not defined in main container. Where is main container? Oh. So this main view is really this state main view. Oh. Token not found. So we're going to create a user. Submitting. Profile saved. And then navigate it to chats here. Bit hard to see, but that's what it is. Go to React, and we see that it's the chats. Chats component, the one that's inside of main container. It's not set up profile. Try it again. We'll go local storage clear. That deletes everything. Refresh. Token not found. We go React. We see that inside of main container, we have set up profile. So we're going to set up profile. Submitting, success, and now we see how it changed from setup profile to chats here. Cool. So that's one way to do navigation in React. Another way, a more sophisticated way, is to use something like React Router. Where's the GitHub one? Training. Yeah, declarative routing for React. Migrating 3x docs. So it kind of shows you how to do a more declarative way to do navigation. Something like this with routes and indexes and all this stuff. So if your application is has a little bit of complex navigation, or if it's simple navigation but it's a lot of navigation, React Router it's probably a good option. If not, you can just do it yourself. Because at the end of the day, it's just state. What's the next task here? I can't. Yeah. So I'm going to show you how the Flux is going to be set up. Now I want to jump into the solution of add contact. I actually show you how we're going to add a contact, how we're going to do the modal, the routes for adding a contact, and all that other stuff. Things that I don't think we're going to have time to do in the time remaining for this lesson. So let me jump to that. So set a profile, chats. So let's see what this is doing now. Probably need to npm install. Sure if we added anything here. It seems we did not add any new modules. So shouldn't have to restart my dev server. This one. Okay. Handle name. Was successful. Cool. So this is a zero state. Looks like you don't have any contacts yet. Click below to start adding contacts. Add. Handle. We're going to add O. Submit. Submit was successful. And that's where it ends. Just it doesn't really render the list of chats yet, it seems. Yeah. Contacts so far. Oh. Oh yeah, because you want to do that real time. Because I think that what you want to do is after you add the contact, you want to see that contact in your view, but you also want the other contact to know that he was added by you. So that needs to be in real time. So this is where this particular section of the class ends, when you add a contact successfully. So here we have a model. On top, we can see what's behind it. And we can close it by clicking outside of it. But if we click on it, it doesn't close. has its own handle, its own input, its own text input, its own submit input. Okay. So let's take a look at these chats. So we have chats React. This chats component, before it used to just return span, right? Now it's an actual component with state. There's an actual chat store. And the chat store has a list of all the chats. For now, it's just an empty list. We're not able to add to it yet. But the chat has a header, the header up here with the tabs, and it has contents. Now, the contents could be a chat list once you have contacts, or it could be what we're seeing right now, which is the placeholder. It looks like you don't have any contacts yet. And it has an add contact button. If we go to chat lists, probably nothing, it just says chat list. Chat header has chats, has some style for that tab. So when you click on that button, the add contact button, on click, when you click, we're going to call an action. One of these actions that we saw from before, which is going to open the add contact modal. The type is set modal key, and the data is add contact, the add contact modal. If we go to the default store, we're going to see that it, through the modifier, which is down here, is going to set the modal key state, and then it's going to emit a change, just like before. Go to main container. And now, instead of just rendering the main view, it's also going to render a modal. And the modal is going to have this component modal, and it's open if the modal key is not null, and then it's going to render the modal children. And the modal children is based on the modal key. In this case, it's add contact, so we're going to render the add contact view. And this, so there's two things to see here: the modal component and the add contact view. So modal component here, if it's open, it's going to render this div with an overlay, and inside of it is going to be a div with the actual modal, and it's going to render the children, any children that you pass inside of it. So here we see that modal, and inside of it, it has children. So we're able to reference those children via the children property. We go to it, the children property will have those children. And it could be dynamic, you know, it could be, as we could see, it could be add contact, or it could be nothing, it could be null. So we go to the model, if it's open, you know, the overlay is that this gray area that you see here. Right. And the model is just a container for the actual children, which is the add contact view. And now, an interesting thing here is that on click, when we click on this model, the box here, is that we want to stop propagation of the click. And we want to do that because when we click outside, we want to close the model. But only when we click outside, only when we click on the overlay is that we want to close the model. When we click inside, we don't want to do that. But if we don't put a handler here, the on-click is going to bubble up to its parent, and the parent says, oh, something got clicked, I need to close the model, and we don't want to do that. So like if, for example, if I remove this, refresh, and boom. And that's unexpected. If you click inside the model, you shouldn't close it, right? So the way to prevent that is to stop propagation of the click event. Add contact. So add contact also has state. It doesn't use a store per se, but the state that it has is that it needs to manage, the regression. It needs to manage, as the user types, what the value of handle is going to be. And also, it has to manage the request state. Because when you click submit, it can go to fetching, and then success or error state. So here we have the add contact header, the handle, the input for the handle. And then we have two other components, request submit button and request message. So these are two things that we actually refactored from before. Request submit button gets a request state and knows what to do with it. And request message also gets a request state and knows what to display. So the submit button, depending on the state, is going to enable or disable the button. And it's also going to change the text of the button, submitting or submit. And now this button, this request submit button component is very reusable. Any button that's really triggering a request can now use this component instead. You pass a request state, and it would know if it should be enabled or disabled based on that state, and whether the text of the button should change. You could even remove the, it's disabled already, so you don't have to remove the click handler. And then we've also split up the message from it. So the message also, there's a component that manages the message to write, to render based on the state. When it's successful, request successful. When there's an error, there was an error. And when it's default or it's fetching, we're not going to render anything. We could render fetching, or getting request, or loading, please wait. But we already but the request submit button is already changing from submit to submitting. And this is a good way to encapsulate it, because now you can swap it. We have another view, the one from before, actually, profile editor. Set a profile, in which the message comes before the submit button. We got different UI requirements. No problem. We just encapsulate everything where it should go based on that, based on those requirements. And we see in a UI, in a particular screen, the message for the request comes before, or is on top of the button. And in another screen, the button is on top of the message. So this gives us that flexibility. Go to chats here. Okay, and then when we actually add the contact. So when we add the actual contact, when the user hits submit, we're going to set the request to fetching, and we're going to create a request. And this is also something new I added here: secure AJAX request. Okay. So when you develop an application, a single page app, you're going to be typically making two different types of requests. A request to an endpoint that doesn't require authentication. For example, when you log in, right? The login route is public; anyone can call it. So that's one that doesn't require authentication. There could be others, based on your use case. Could be that your API is public, for some reason. But there's also use cases where it needs to be authenticated, where you need to pass an actual token or some type of scheme so that the server can authenticate the request. So, and that's what I'm calling a secure AJAX request. It's one that actually sets the authorization header. And in our case, it uses the authorization token that it gets from local storage. So this, every time you use a secure AJAX request, it's gonna be set with the authorization header. There's also the standard AJAX request, which in our case, all it does, it disables caching, disables client-side caching. Why? Because we are interacting with an API server that is really managing dynamic data. So we don't really want to cache that data. You may have use cases that you use an API server and you want to cache, and you want the browser to cache some of those responses. In that case, you might want to pass the right headers. You might not want to set these headers. But in our case, we don't want to cache an API calls to an API server. So I created this standard AJAX request. So the secure AJAX request extends that standard AJAX request. And then there's the actual, just the base AJAX request, which exposes two functions, get and post, and has these helper functions to request a get and request a post. So it's encapsulating some of the nitty-gritty details of making a request and how to set the headers depending on your use case. So here we create an instance of that secure AJAX request. We create the data that we're going to pass to it, and then using that request, we post. We're going to post to the contact route, passing the contact data, which is basically the handle of the contact that we want to add. And then we set, when we get a response back, we're going to set the request status successful. We're going to see how many contacts we have. And then once we're done with that, we slow it a little bit here, just for us, for demonstration purposes. And then we're going to say that the contact was added. And when the contact was added, that'll probably trigger a state change in the store, probably the chat store, so that we can render the list of contacts. But we don't have that ready, so it's commented out. And if there's an error, also we set the state to has error. And we already have the request message and request to me button, knowing what to do when there's an error. We only need to set the state. Cool. So let's see, actually, before we go see what the route is doing, let's see if we can get some of these contacts to show so far. Well, let's see what the request of this is. It gives us a string of all the, an array of the handles of the contacts for that user. So what we could do is, let's see if we can make this work. Response. Cannot find that. Chat actions. Box chat actions. Chat action types. So chat actions. I do that. I don't think I did it in the solution. Box chat. Yeah, there's no chat actions, but we can do it real quick. Actions. What was the name of that thing? Contact added. Contacts. And we're going to go constellation object, and use some type, chat action types. chat action types. Yeah, show the contact model. No. Some data. The context. And then we're going to dispatch it. So we also need dispatcher here. Dispatcher. Action. Chat actions. Okay. So chat actions are contact added. Should we get there? So now we need a chat store to handle that action. Case chat action types dot contact added. I'm gonna go modifier dot set contacts, and it's going to be action dot data dot contacts, I believe. And then we need a modifier function for that. Set contacts. So we're going to go to stable chats. Here we're simplifying it. You know, I mean, not every contact you add you're going to have a conversation with, but we're just going to simplify it for the purposes of the project to keep things simple. You're going to say every time you add a contact, it's going to be equivalent to adding a chat. So we got a chat. Let's not forget to emit the change. Okay. And now this one is it's getting the state from the store, but it's not listening to it. So we just need to add the corresponding function so that you can listen to it. A component did mount, a component will mount, and the handle change stuff. Or here we could go also with the get state function. Returns this. There's that. Which one had the container? So these are using not default store, but chat store. Okay, and chat list is going to need the contents. Also, set the chat in. This chats. So here we're gonna return. We're gonna map this array of chats to an actual DOM representation. Map. Let's go. Yeah, something extremely simple. Zero state, but folder contact one. It's not zero state anymore. Check this, chats. Just check this. Chats, chat. Placeholder, contact button. All right, let's see how that works. Just crossed. Okay, and 30. Successful. Get stays on a function, checks out. State. Ready to bind it. Handle store change. Yeah. I need to bind it like I bound main container. Right here. Yeah. I don't have to bind handle store change. Why is that? Is because the store is gonna call this handler store change, and this object is not gonna be bound to this React component. So to do that, we have to call bind on it. So everything is gonna get called. This handler store change is gonna be that function, but bound to this object. So let's try to query again. Actually, query is probably added already. So submitting. Okay, chat list about a React element and no value return. You may have returned defined an array or some other invalid object. This is chat list. Where are you? Here. So we need to do the thing with React, you always have to return a top level element, right? And before I was returning just a list of divs, but it needs to have one at the top. So running out of keyword names. Okay. Submit successful. It should have a unique key. Information. This is a warning. And it's true though, like it shall actually have a key property, but this is not navigating for some reason. The default profile, editor, chat, add contact, yeah, contact added. Okay, so what's happening here is that we are passing the state for what's behind here. And you probably can't see it because I put it in white, but it should be black. Chats, header. Yeah, there you go. Chat. Yeah, so there's a bug here, but we are rendering this stuff. You just can't see it because it's white. It should be black. There you go. So we're adding things. It's all chats for some reason. Chats. I think I know why. go to chat list. So I have to wrap it in curly brackets. There you go. Okay, so we're adding a chat, we're adding contacts that are equivalent to chats, and they're getting added behind this modal. For one, they're in white, so you can really see it even behind the modal. So I changed that. And another one, there was a bug that I was just printing out chat instead of the value of chat. So that's what I just did by putting it in curly bracket. But now it's still an issue, right? The modal is still up there. And that's because we haven't fired the action to close the modal. To do that, there's many options. You know, we could have the default store, listen to this contact added action, and then close it. Or we could fire the actual action from the action creator that we already have. So that's what I'm going to prefer to do. So first I'm going to add the contact, and then do I have default actions here? Default actions. That should close it. There you go. We closed, and then we can see all the new guys. Cool. And we can look at the route also. Running out of time though. The route to add a contact user contact here. So here, the first thing it does is that it gets the authorization header. Because remember, this contact is now authenticated route. So we need to authenticate who's calling it. So we get that and we verify. And after we verify, we get the verify returns the decoded values. And we did the decoded values. And here we should have the decoded. And this one has a, if it doesn't verify, I believe it throws. So the processing will stop. JSON web token, double check that. JSON. Synchronous, no supplier. Yeah, if not, it will throw the error. So it's going to throw the error if it's not valid, if it doesn't verify, and this will process it. This process will stop. So we go through here. We get the handles. We make sure that also that the contact you're adding hasn't already been added. No, first we make sure that whoever is requesting this, we get this from decoded handle. So we make sure that that user actually exists, the one that's requesting it, and then we add it. We add it to the contacts by user. So every user is going to have a list of contacts, and that key is contacts by user. And that key is going to be keyed based on the handle of that user. And then we're going to push to it the actual handle that we passed, the handle that the user wants to add. And then after that, if it's all good, we're just going to return all the contacts for that user back to the UI. Okay. Here, if we don't find the user that made the request, we say this is unauthorized. But here too, since this verified catches, it's probably a good idea to wrap it. catch, we could just do this. Important to do a return here, because notice a single, it's different than your more traditional web servers. Traditional web servers, every request creates some process. So when you respond to that request, the process ends. In Node, it's a single process for all requests. So when you respond to a request, the process will continue. It will continue executing what's next. So you need to make sure that you want a return after that, so that what's underneath it doesn't execute. There's a reason for that. There's the advantage with the event loop and the synchronous nature of Node. It's very eventful. It's always when there's a request out there, it doesn't wait. The process doesn't wait for that request to finish. It just serves the next request that Node API gets. So whenever there's a response, for example, here, when we make a request to Redis, in the meantime, while Redis is responding, the Node process can serve other requests. And then when it comes back, there'll be an event saying, hey, this is ready. So it will call this callback and it will execute. That's a whole other topic. But Node is very popular with APIs because it's very cloud friendly, very economical. It performs well with a large load, and it's very useful for applications that need to communicate with various other services. Okay, I think that's it for today. I will, next time we're going to talk about making our application real time with WebSockets and Socket.io. Okay, well, thank you. Have a good week. Oh, I forgot. Next class, I had to reschedule for the week after that. So next Thursday, we're not going to have class. Our last lesson is going to be the week after that. I believe it's let's check my calendar here. Let's see, next time we have class. So next Thursday, June 15th, we're not going to have class. We will have our last lesson on Thursday, June 22nd. Okay. All right, see you then. Bye.